All right, so after we've wrapped up the law of sines, now we want to talk about the law of cosines. Kind of a good news, bad news situation. The formula is tougher. It's harder to remember. There's 3 of them, but we'll look, it's actually just the same formula, 3 different flavors of the same thing. Just rearrange it. The nice thing is there's never an ambiguous case here, right? If you have to use an inverse cosine function, we know the range of that function is from 0 to 180 degrees, so it'll always give you the correct answer. So you don't have to worry about the ambiguous case. Now, a lot of times, what you're going to get tired of hearing me say, is that once we get the first law of cosines done, we want to go ahead and use law of sines. And then if you have an option, well, whenever you have an option, I would always recommend starting with the smallest possible angle. If you know lengths of sides, you can tell which angle is going to be smallest. If you always start with the smallest possible angle, you should avoid that ambiguous case with the law of sines. Because it's usually easier to use the law of sines here after our first step with the law of cosines. But again, always, if you have a choice, I would recommend start with the smallest angle. Once you find that, find the next smallest angle. And then once you know those 2, you can find the last one, just to avoid that ambiguous case. So here's our formula. One thing to notice is, we labeled the triangle the same. If you cut off this back part, it's just the Pythagorean theorem, correct? Well, it looks like it. It's not a right triangle, but it looks like it. And what you'll notice here, if we just look at this first case, we have a squared, which is a side length, equals b squared plus c squared. Then it's minus 2bc. Notice b and c are the letters that are on the side here. Like this side, a squared only shows up on the left-hand side. So b squared plus c squared minus 2bc times the cosine of a. Right? So that's where the angle a shows up. So that's one form of it. If you notice, the other forms are we just switch places around, right? Here, b squared's by itself. You notice we have the cosine of b over here. Here we get a squared plus c squared and then minus 2ac. Here, c squared is by itself. You have a squared and b squared on the right-hand side. You have a and b on the right-hand side. And then you go ahead and use the angle C over here. Okay, so don't think of it as 3 completely different formulas. Just realize that whatever side here is by itself, it's going to be the opposite angle over here. Okay? You're going to use the other 2 sides squared added together and then subtract 2 times those 2 side lengths. So that's how we're going to apply that. So let's go ahead and take a look at an example. And, I guess before we do that, the times that we use this, pretty much any time you can't use law of sines, you have to use law of cosines. So it's going to be any time you don't have an angle side pair. It ends up is we use this when you're given either a side angle side, right? So you maybe have side C and angle A and side B. You don't have an angle side pair. Or you can use it when you're just given the 3 sides, the side case. Okay, this one tends to be a little bit easier to use. This one, I'll show you a little trick I like to do where we kind of rearrange some things and make it work out nicer for us. So let's go ahead and take a look at our first example. All right, so first example, we're given some 3 facts about a triangle. We're told that side A is 11, went ahead and labeled it. Side C is 14, went ahead and labeled it. Angle B is 34 degrees. Okay. So as we look at this, again, I would always try to use the law of sines first. It's easier, the formula is easier to use, it's less typing in your calculator, but here we have no angle side pair, so it's not going to work. Right? We do know 2 of the sides, and this B is the unknown side. So if you know 2 of the sides, and you can't use a law of sines, we're going to have to use the law of cosines. B's the one we want to find, so we're going to use the version of the law of cosines. That is b squared equals a squared plus c squared minus 2ac cosine b. And you're going to want to, I would recommend kind of testing yourself as you do these and just try to write it down, then check it, see if it's right. If you do that a few times, you'll you'll get that pattern there, right? So b squared by itself, a squared plus c squared, and then minus 2 ac cosine b. So now this is a really nice case here. We really just get to fill things in. We know a, we know c, we know angle b, we fill it in, type it in our calculator, take the square root. That's what you do. So let's see, we get b squared is 11 squared plus 14 squared, 2 times 11 times 14 times the cosine of 34 degrees. So we'll go ahead then, when you type that in, I wrote it down, I got 61.66, but that's b squared. So a lot of times, as soon as I get that number, I'm going to hit square root and then answer. And I'm going to square root it, and that gives us that b is equal to 7.85. And you might take a second and check that on your own calculator just to make sure you're able to get that. So just take a second and try that. Okay, now that we found that, at this point, we got a couple options. Some people, I mean, I guess you could, I don't know. I'm going to definitely use the law of sines here. It's so much easier. But here's where you want to be careful about which angle we find next. So as we look at this, we know that side B is 7.85. That's the smallest side, correct? This is the middle length side. This is the longest side. So we know that since the longest side has to be opposite the biggest angle, if there is an obtuse angle, which there could be, which would cause problems with the law of sines, correct? So if there were an obtuse angle, I think there might be, yeah, there is actually, but it would have to be C, correct? You can only have one obtuse angle in a triangle. So what I'm going to make sure I do first is I'm going to find what angle A is. If I find angle A, I shouldn't even have to consider the ambiguous case because it can't be obtuse. It can't be bigger than 90. So what I'll do here is the sine of 34 degrees over 7.85 equals the sine of angle A over 11. Again, find the smaller angle. The ambiguous case should not be a problem then. So we cross multiply. Let's see, 11 times the sine of 34 degrees over 7.85. And I work that out, and we get A is equal to 51.59 degrees. You might want to try that on your own. Now, if you did notice here, what would that end up being? 130? No, it's just not. It can't be. It's got to be this angle because it's going to be the small, right? We know the bigger angle would have to be C. So here we get angle A. Now that we know angle A and we know angle B, and again, I just did the inverse sine of this, correct? That should be, we should have just got done doing a bunch of those. So then for angle C, is going to be 180 minus 51.59 minus 34, and that's going to give us that angle C is 94.41 degrees. So we actually just solved the triangle there, and it works out. Now, because I knew I was going to be showing you this, I went ahead and checked them. Like, not only did I look at the longest and shortest and all that stuff, but I actually, a nice way to check here is if I go and do the sine of 34 degrees over 7.85, and then I do the sine of 51.59 degrees over 11, and then I do the sine of 94.41 degrees over 14, these should all be roughly the same number, right? This is just the law of sines, right? I'm using the law of sines to check my answer. So let's see what we get here. We get the sine of 34 degrees divided by 7.85, 0.0712. And then we have the sine of 51.59 divided by 11, 0.0712. And then we have the sine of 94.41 divided by 14. And that gives us 0.0712. So now you could be off a little bit. You might get a 1.3 or a 1.1, but it should be about the same. But if we'd have goofed up, and this one though, if you'd have tried to find angle C first here, it would have given you the supplement of this, would have given you the wrong angle A, and your ratios would have been off. It's just, so again, start small, small to large. Right? You'd like to find your obtuse angle just by doing 180 minus. Just, if you could do that, you should avoid a lot of mistakes. Now, if you're still given a side-side-side, or side-side angle case, the ambiguous case, and use the law of sines, you still have to consider them both. You can't avoid it there. But everywhere else, you can kind of avoid the problem occurring. Okay, so here's our second example. We're asked again to solve the triangle, but this is going to be a side-side-side case. Now, you can, when you do the first step, you could really do any angle. The law of cosine always works, but still, just to be consistent, I'd still recommend start with the smallest and just work our way up. Just nice to have a system. So if I look at this, the smallest angle, which angle would that be? So this would be, if A is 12, then angle A would have to be the smallest angle, correct? So I need to write the formula that has A, the cosine of A in it. And that would be where A squared is on the left, B squared plus C squared minus 2BC cosine A. Now, this doesn't have to be difficult, but just from years of teaching this, I tend to know where people miss this, and it tends to be with the algebra. Is once you put all those numbers in there, it's really easy to kind of, I don't know, people will want to like take B squared plus C squared and then subtract this number from it, which you can't do because it's being multiplied. It just doesn't go well. I'd encourage you to kind of experiment with different techniques, but I'm going to show you how I would recommend you do it on these. And I think it's really easy. It keeps us to just doing 1 or 2 lines in the calculator and kind of avoids a lot of the order of operations issues that can arise for a lot of students. So what I'm going to do is I know that I want to get cosine of A by itself. I'm going to go ahead and work to do that right away. So the first thing I'm going to do is I'm going to take this giant term right here. This is before I put any numbers in. And I'm going to go ahead and add it to both sides. So I'm going to have 2BC cosine A, plus A squared equals B squared plus C squared. So I just took this, added it to both sides. Then I'm going to subtract A squared from both sides. I normally do those both at the same time. All right, so now on the right side I have B squared plus C squared minus A squared. And then I just want cosine of A over here. I don't want the 2BC. Since it's being multiplied, I'm going to divide both sides by 2BC. So cosine of A, B squared plus C squared minus A squared over 2BC. To me, it's 100% worth it to rearrange this equation first. It's how I personally do it as well. You're going to get it rearranged. Now I know all these numbers. I know little a, little b, little c. I just have to plug them in, type it in my calculator, I get a number, take the inverse cosine, I get the angle. Okay. To the point where some people even memorize this formula, like this form of it, which I guess I could. I just usually rewrite it because I don't mind doing algebra. So again, I added this negative 2BC cosine A was here, so I added that to both sides. Subtract A from both sides, divide by 2BC. Really makes a nice formula there for us. So now for the cosine of A is 27 squared plus 20 squared minus 12 squared over 2 times 27 times 20. So again, just be careful, put the numerator in a parenthesis, put the denominator in a parenthesis, all that fun stuff. Let's see. I didn't write down what I got here. So for this, 27 squared plus 20 squared minus 12 squared is divided by 2 times 27 times 20. So I just get the cosine of A is 0.9120, which is a good sign, correct? I mean, but it's less than 1. If it wasn't, that would be problematic, right? So I get that number. We'll do the inverse cosine of that number. And that gives us 24.2 degrees. So angle A is 24.2 degrees. So again, now if you want to try to just plug it in right here and then rearrange it, you should still get 24.2 degrees. But this is again, this seems to be the way that tends to help the most people. So at this point we have one angle. So now we have an angle side pair, correct? So now I'm going to jump to the law of sines, and here again I have to be careful. I have two options. I could find angle B or I could find angle C. I'm absolutely going to choose angle B, right? Because that's going to be the smaller of the two angles, right? If it's smaller, it can't be obtuse, it can't be bigger than 90. So the next thing I will do is write, and again I'm going back to the sign of the law of sines. It's just easier to work with, it's fewer steps. I prefer it. Over 12, and then we said the smaller angle C, so the sine of C over 20. So 12 times the sine of C is 20, sine of 24.2. So we get the sine of C is whatever that number is. Then we do our inverse sine function, and we get that C is 43.1 degrees. Okay, so we found that next angle. Now at this point, since I know two angles already, I'm just going to subtract them to get the third one. So I'll do, for angle B is 180 minus 24.2 minus 43.1, and that gives us 112.7 degrees. Okay, so if we would have done angle B second, we would have had to consider the ambiguous case. We would have gotten it wrong. So that's why, again, using that law of sines, always smaller angle first. If you do the check here like we did last time, I checked it, it works. All the ratios are the same. I should have probably written down what they were, but I didn't. So. Okay, so this last one here from your worksheet, we're given these conditions. I think it's a mountain that you're measuring, or a hill from one side to the other. So we know this angle labeled C is 82.4 degrees. We know the left side of that angle is 388 feet and then 212 feet on the right. So let's see what we have. So this is a side angle side case, correct? So because soon we're going to be solving just triangles. Like you'll have to decide whether do I use law of sines or do I use law of cosines. So in this case, since it is a side angle side, we don't have the opposite pair, right? The angle side pair. We're going to have to use the law of cosines. Here I know angle C, I don't know side C, so we're going to use the version that says C squared equals A squared plus B squared minus 2AB cosine C. And then from here, we're just going to fill in our facts, right? And we should be able to get this pretty quickly, I hope. So C squared is, so A is 212 degrees squared plus 388 squared minus 2 times 212 times 388 times the cosine of 82.4 degrees. So that's just going to be some big number, and then we're going to square root it. So you could even type the square root, then type the whole thing, and then just have the answer. But hopefully, however we type this in, we get that side C would be 416.8 feet. We get that? Yeah, 'cause it was a big number before you square rooted it. And don't forget to square root it. I've done that, where I put like a giant number down, and then you're like, wait, that doesn't seem right. So, we good to go there? Everybody okay? All right, well, good. So that should do it.